Welcome to video 3 in the female reproductive lessons. We're going to start this video by sort of recovering the development of the follicle sort of in an overview fashion to give you an idea of how it fits in the menstrual cycle and how it leads to ovulation. So this is a really central figure for this. I like this figure. It takes you through the different stages of follicular development and then up to ovulation. And of course, the stage of the menstrual cycle. This is basically the follicular stage of the menstrual cycle, what you're seeing here, up through ovulation. So this figure covers the development. Really, what we're going to talk about mostly is the transition phase from secondary follicle to dominant antral follicle. So this would be your post-puberty development during the menstrual cycle. Again, this is sort of a description of what's happening during the follicular phase of the menstrual cycle. So these are changes that take place over time. And again, this figure is mostly this stage here. What we have here is a process that really starts with the secretion of FSH from the anterior pituitary, which of course is happening post-puberty. And this FSH acts upon granulosa cells in the follicle to increase estrogen production. Okay, so you have FSH, in the mature woman, and a number of follicles are recruited, and in these follicles you are increasing estrogen production. This estrogen does two things. First, it increases FSH receptors, increases estrogen receptors. Basically what it does is it increases the number of granulosa cells. So you get a big proliferation of the number of granulosa cells. Okay, so this increases the potential to secrete a lot of estrogen as these granulosa cells become more and more, proliferate more and more. Now I said the potential to increase estrogen quite a bit because at the same time, estrogen is feeding back in a negative manner upon the hypothalamus and the anterior pituitary. So at the same time you're causing the granulosa cells to proliferate, you have this estrogen which is keeping the secretion of FSH under control through this negative feedback mechanism. So a lot of estrogen is feeding back and keeping this FSH under control so that although you are increasing more estrogen, it's sort of a controlled increase in estrogen. At the same time as you cause these granulosa cells to proliferate, you have the potential to generate quite a bit more, okay? That progresses to a stage where now your granulosa, the FSH acts upon the granulosa and you increase the number of LH receptors on the granulosa, okay? And as you'll find out in a moment, that has a role in generating androgens, which are a substrate for estrogen production. LH also begins to act upon the theca, and this is where a lot of your androgens are produced. And again, androgens, a substrate for estrogen production. So the androgens are produced in the theca, and they then, the androgens diffuse to the granulosa where they feed in as a substrate for estrogen production. So this is what's actually happening here in steps 3 and 4. On that slide, you increase the number of LH receptors on the granulosa. That's going to cause cholesterol to be converted to progesterone in the granulosa cells, okay? That progesterone diffuses to fecal cells, okay? And that can be used to generate androstenedione here, okay, in the fecal cells. Now, in addition to that, in step 4, as I showed you, you also have LH binding to the fecal cells, and it's also causing generation of even more progesterone and even more androstenedione. So the two are combining here to produce androgen, okay? And that androgen, you have production of progesterone here, you have production of progesterone here, and the progesterone feeds in here. So we have more and more progesterone, and that becomes more and more androstenedione, and then the androstenedione diffuses back to follicular cells, and it goes to produce testosterone, which is converted to estradiol, estrogen. So the estrogen is finally produced in granulosa cells. So the LH acts through the granulosa cell here and the thecal cells here to produce androstenedione, which eventually becomes estradiol through the auspices of the enzymes in the follicular cells. And remember, aromatase is prime here, converting testosterone to aromatase, and FSH, this is how it acts to increase estradiol. So we have FSH and LH acting on granulosa and theca to produce more estrogen. And so we have more and more estrogen being produced under the influence of LH and FSH here, as we have many, many granulosa cells that are proliferating here and increasing the potential to make estrogen. So our follicular cells are proliferating, we're increasing the estrogen, and we're increasing the potential to make even more estrogen. We have our gonadotropins here, which are causing that estrogen to be made and released. And as our follicular cells develop more and more and proliferate more and more, and we increase our estrogen more and more, what happens is eventually you get to the point where you get this big increase in estrogen, reasonably big, because you've just generated so many granulosa cells that the system just gets to the point where you get this nice big sustained increase in estrogen. And the estrogen goes up, and if it stays high enough or long enough, which it will, this negative feedback becomes a positive feedback. And all of a sudden we have this huge level of estrogen that is causing the hypothalamus to release large amounts of GnRH, the anterior pituitary, which is causing the release of a large amount of LH. And what we get is what's called an LH surge from this positive feedback, okay? And that LH surge, this huge increase in LH levels, has a number of consequences. First of all, it decreases estradiol back down from the high level that you had in step 5 on the last graph, and step 6. And it increases progesterone production, and this increases the production of the enzymes that produce prostaglandins, the most important of which here are PGF2 alpha and PGE2. Okay? The LH surge causes the neutralization of oocyte maturation inhibitor. Remember, this is in your liquor of folliculi. Okay? And this is what's causing you to stop part of the way through that first meiotic stage. So now with the LH surge, we neutralize the oocyte maturation inhibitor, and that helps reinitiate the meiosis, and now you progress through the first meiotic division, again initiated by the LH. At the same time, we have the increased prostaglandins, which are increasing collagenase, which is going to weaken your follicular wall. And the increased PGE2 is increasing blood flow, which is causing the follicle to swell. So we get this swelling with the weakened wall, and the follicle literally protrudes out of the ovary. You can actually see it, and since I'm a veterinarian, I can tell you you can feel it. We won't go into the details of how veterinarians do that. You can ask me if you want to know. But in the end, you get follicular rupture, and the ovum is released and gathered up by the fimbria, and are gathered into the fallopian tubes. And the follicular remnants they undergo a process called luteinization. That means they become a corpus luteum. And the corpus luteum secretes hormones which prepare the uterus for implantation. And eventually, if fertilization doesn't take place, it will regress and become a corpus albicans. Okay? All right. So that is the end of this video on folliculogenesis. And when we pick it up again, we'll start with the regulation of the menstrual cycle and an in-depth discussion of the hormones that are involved.